Hello everyone. So our today's topic of discussion is complex power, and under this topic we will go through these mainly three topics, like why we are studying the complex power, what is the significance of complex power, and next is the definition of it, how it is being defined. Then the next part will be what are its parts and what is their significance. Okay, so now moving further, first topic is why we are studying the complex power. The first and foremost question which comes into our mind is why we are studying the complex power so much every time, when it is coming into the picture. So we are studying complex power because it holds so much of information into it. And why, I will tell you what are those informations. Like first and the foremost information is the mode of complex power is apparent power. So the first information it gives us is the apparent power. Okay, next it gives us the real power. Third, it gives us the reactive power. Fourth, it gives us is power factor or the power factor angle. So this much of information it gives us, which is very much of importance from the electrical point of view, and that is the reason why we are focusing so much on the complex power. So next thing is into the series of topics, what is the definition for it, how we define the complex power. The complex power is being defined as it is the multiplication of voltage phasors RMS value with complex conjugate of current phasor RMS value. This is the definition for the complex power. Okay, it is also represented as, after solving all of this, the final quantity will come into the form of a plus jb. Okay, so it is finally being represented as p plus jq, and I will explain further what are pq. Here p is the real power or the actual power, and q here is the reactive power. Okay, now the modulus of complex power will be p square plus q square, and that is known as the apparent power. Okay. So these are the things I told you before, that it gives you these informations to us, like the real power it gives, the reactive power it gives, and the third one we just now calculated is the apparent power. Okay, now further we will explain it in more detail. Let us take one example. Let us take one AC load here. I current is flowing and V voltage is source is applied. Okay, here V is the voltage phasor, and it is being can be written as Vm with angle theta V. Okay, and I is the current phasor, it can be written as Im angle theta I. These are the phasor quantities. Okay, And if now we write the complex power from the definition, it will be Vrms multiplied with Irms conjugate. Okay. Now let us write one by one what is Vrms from the above equation. It will be Vm divided by 2 and Irms will be Im divided by root 2. Now further we will put that into the equation. So the complex power will be Vm divided by root 2 angle theta V multiplied with Im divided by root 2 angle minus theta I. Why this minus has come here? Because of the complex conjugate. Okay, and if we solve this further, we can write it as Vm Im divided by 2 angle theta V minus theta I. Okay. Or it can also be written as Vrms Irms angle theta V minus theta I. So as I told you before, it gives us, like I told about real power and reactive power and apparent power. Now the fourth one, why we are studying the complex power, is the power factor angle or power factor. So in the previous equation, this angle, that is theta V minus theta I, is known as the power factor angle, or it can, here we are representing it as by theta. Okay, this is our power factor angle, and cos theta can be calculated, which will be power factor. So these are the four informations it gives us, or we can say it holds. Okay, now we will come back to our this equation which we wrote here about complex power, that is Vrms Irms angle theta V minus angle theta I. Further expand this, so it will be equal to Vrms Irms cos, I am writing here theta directly, j plus j Vrms Irms into sine theta, and this is our final expression for the real power plus, and this is our final expression for the reactive power. Okay, now since we have calculated the real power and reactive power, we will write it here Vrms Irms into cos theta. This is our real power. So we will try to understand the significance of these powers one by one. Okay, we say this power as the real power because this is the actual power, this is the actual power absorbed by the AC load. Okay, this is the power which will be dissipated into the load, or which will be delivered to the load, or the power which will be absorbed by the load, and it is measured into watts. Okay, now we come to the reactive power, which is Vrms IRMS sine of theta. This is our reactive power. This is measured into volt ampere reactive. Okay, and as such, this power have no physical significance, but that doesn't mean that it is not necessary. It is very much necessary as the real power is, because it allows, or it allows the energy transfer between storage elements. Okay, what it means is, like, as we all know that the AC load will be having either the capacitor or the inductor with the resistance, or both of them all together. So the reactive power signifies this, that how the transfer of energy is taking place from the source to the load. It is happening with the help of reactive power, and this is the significance of this, and it is very much necessary as the real power is, because since there is no power loss into the storing elements, but just only the transfer of energy. So very important. Okay, and there is one more information we were left with, that is the complex power is measured in volt ampere. Now there is one more thing here, that is the power triangle. Okay, since we know that this is equal to JQ, and it can be written as P Q, and this is our S with angle theta between them. This is the power triangle, just as the impedance triangle. So from here we can see that tan theta will be equal to Q by P, or we can say that from the similarly from this power triangle we can calculate the power factor, that is P by S. Okay, so this is the information being given by the power triangle to us. I think I have covered all the topics under this. Yeah, okay, So if you still have any doubts or still any queries regarding this topic, you can comment into the you can comment below and let us know that. If you need to know anything else about it, we will try to explain again. And if you like our video, please do subscribe this channel if you're